So today's big focus is understanding how divisibility and factors work in math, which help us in larger problems and many real-life situations. So I won't spend a lot of time on this specific page, the first one of Lesson 17, Grade 6, Module 2, but I want you to think and just explore this, how you think these numbers would go into these circles, assuming that the circle numbers would be factors of the numbers that are up here. So this would be a factor of 24, so 24 would end up in the 2, but 24 might also end up in the 4, but not the 5. So work on this as best you can. So here's some divisibility rules that can help guide you on bigger numbers. It is always divisible by 2 if it's even. And here's, of course, what even means to review that. For 4, it's always divisible by 4 if the last 2 digits are divisible by 4. So in the number 38,416, the last 2 digits are 1 and 6, or 16. And 16 is divisible by 4, so therefore the whole number is divisible by 4. Any number that ends in a 0 or a 5 is divisible by 5, and obviously if it ends in a 0, it's also divisible by 10. For 8s, the last 3 digits have to be divisible by 8. So I look at 973,160, and I see 160, and I know that's divisible by 8 because 8 times 20 equals 160. So therefore the whole number is divisible by 8. For 3, I add the digits up. If the digits add up to a multiple of 3, or a number that is divisible by 3, then the whole number is divisible by 3. So in 744, 7 plus 4 is 15, and 3 times 5 is 15. So 15 is divisible by 3, therefore 744 is divisible by 3. Divisibility rule for 9 is like 3, except for the sums have to be a multiple of 9, so it has to be divisible by 9. So when I have 46,341, I add the 4, 6, 3, 4, and 1, each digit, and I get 18. 9 times 2 is 18, and therefore 18 is a multiple of 9 and divisible by 9, so 46,341 is divisible by 9. And then also, if a number is divisible by 9, it is also divisible by 3. Just like with 10. If a number is divisible by 10, ends in a 0, that means it's also divisible by 5. This would be a great time to pause the video and write all of this stuff down on your practice or in your math journal. These are notes you definitely want to keep for the future. For these exercises, you'll want to refer back to your notes and see if these numbers are divisible by the following factors. So when I look at 2,838, I want to ask myself, does it end in a 5 or a 0? No, so it's not divisible by 5 or 0. Is it even? Yes, so I know it's divisible by 2. And that one's not on here, but I know it's going to be divisible by 2. I look at 38, the last 2 digits. Is that divisible by 4? Well, I know 4 and 9 is 36, and 4 and 10 is 40, so I don't think it's divisible by 4. In fact, I know it's not divisible by 4. I look at the all the digits and combine them. So if I add 2 plus 8 plus 3 plus 8, I get... I'm letting you do that. That's correct. I get 21. Now 21 is a multiple of 3 because 3 times 7 is 21. So I know 3 is a factor, but it's not a multiple of 9. So I know that this number is divisible by 2 and by 3. And that's all I can say for right now. So I've done that first example for you, and I didn't have to add the 2. I just did that for fun. But I was able to narrow down that it couldn't be 9 because the digits do not add up to a multiple of 9. It is not divisible by 4 because the last 2 digits are not a multiple of 4. You can go ahead and finish the rest. So the main focus of this lesson is to learn about the 3s and the 9s and how adding the sums of the digits can really help you figure out if it is divisible by 3 or 9. So remember that if the sum of the digits is divisible by 3, the entire number is divisible by 3. And if the sum of the digits is divisible by 9, it's divisible by 9 and by 3. And that wraps up Lesson 17 from Grade 6, Module 2.